And so we're launching in 3, 2, 1, go! Hi, I'm George and welcome to the Typhoon 2 series. This is our level 2 certification rocket. Now it's very similar in design to our level 1 rocket that we flew a few years ago, but this one is bigger and stronger and can also fly on 54mm J&K motors. Now, but because we're also a water rocket channel, it can fly as a water rocket as well. And in this episode, we're going to have a look at its first test flight as a water rocket. And then if you're interested in seeing the full construction details how it was built, you can follow the series along right here on YouTube. But anyway, let's have a look at what all the fuss is about. This rocket's a little too big to launch at the local park, so we're heading north about 6 hours out of Sydney to New South Wales Rocketry's high power launch site at Malali. The day of the launch was absolutely gorgeous with blue skies and very little wind. Ideal weather for rockets. The rocket itself is too long to fit into our rocket box, and so it has to poke out through the end. For the shock cord, we're using this 5mm braided nylon line. Thread this through. The end of the shock cord just attaches to the top of the pressure chamber with a steel pin. We decided to use one of Horizon's 60-inch ultra lightweight parachutes, as this is a fairly heavy rocket. We don't have to pack it very tightly, as there's plenty of room in the rocket itself. In this deployment mechanism, we've changed how we stretch the ejection rubber bands, because they need to be stronger in this rocket. We first lock the deployment mechanism in place by turning on the servo and then turning it off again. Then we use a hook and stretch each of the rubber bands one at a time to prime the ejection mechanism. This is a lot easier to do than trying to stretch all of the rubber bands at the same time and then trying to lock everything in place. We just tuck the shock cord in there, and the pink section is just heat shrink tubing that prevents chafing on the tube edge. The whole payload can then be attached to the pressure chamber. And the whole thing gets screwed down with 8 M4 bolts. This is so that the shock cord won't pull it off sideways during deployment. The rocket's capacity is about 20 litres, and so we're filling it here with about 5.3 litres of water. A little less than a third, so we get better acceleration on launch. The launcher gets fitted next. We're using a 1.5 meter long launch tube here, so it's a little tricky to get on when everything's horizontal and the tube sags under gravity. We have to carry the rocket out nose down so that we don't spill any water out of the nozzle. Then we hook it up to the air supply and also the remote trigger. Then the altimeter and timer get armed and the nose cone gets screwed on top. It's much easier doing it this way than needing a bunch of access holes to reach everything inside. The rocket then gets lifted onto the launch pad. Now watch your fingers. Lift. A bit more, Okay. Yeah. Of course, we need a team photo just before launch. Alright, let's launch this thing. Okay, start pressurizing, please. Okay. 3, 2, 1, go! Shoots out. Yes. Go! It's a heavy rocket.
Heads up! Heads up!
Oh. It's okay.
Thanks. Yeah.
Small.
So let's have a look how high the rocket flew.
This is Luigi
Other side.
flying on an F44 motor.
Keep going.
Should go to around 1,270 feet.
667.
At A5.
That's 667 feet or 203 meters. Which is less than we were expecting, but it was also launched at a lower pressure than originally expected. We were targeting about 786 feet at 300 psi. What happened was that because of the large volume inside of the rocket and the hose having a fairly narrow restriction at the rocket end, there was a pressure gradient in the hose, so that at the filling end, where the pressure gauge is, it was reading a higher pressure than what was actually in the rocket. You can see here when the pressure reached 300 psi and Dad turned the air off, you can see that the pressure dropped back down to 200 psi as the pressure in the hose equalized with what was in the rocket. You can also see the pressure jump to 400 psi when the air was turned back on before the air properly flowed back into the rocket. So we left the air on and launched the rocket. In the end, we believe there was about 270 psi in the rocket at the time of launch. The simulator also predicted a pressure of around 270 psi to reach the 667 feet. So that's the flight. Next, we'll go right back to the beginning and we'll have a look at the construction details of this rocket. And in some of those episodes, we'll also cover where the rocket got its name and also where Air Command got its name, because those two things are related. Now, don't worry, this series is running in parallel with the Horizon project. We've got some videos coming up for that as well as some other project. But anyway, that's all for this week. Thanks for watching and we'll see you next time.